Hi, we are from College Matriculasi Selangor and we are from Group Nova. Here is a view of our group teacher and group members. These are the contents that we are going to cover. Introduction. A rocket is a spacecraft, aircraft, or vehicle that obtains thrust from a rocket engine. Moreover, rocket engine exhaust is formed entirely from propellant carried within the rocket, and it works by action and reaction and pushes rockets forward simply by expelling their exhaust in the opposite direction at high speed, and can therefore work in the vacuum of space. Our objectives of building this model are: first, to build a model rocket using physics principles and principles of rocketry. Second, to design our structure on paper based on our readings and observations about aerospace engineering. Third, to learn and explore about spaceflight, aerospace engineering, engineering design and redesign. Fourth, to share our ideas in building a model rocket to a society. The physics theory applied to our model are Newton's first law, Newton's second law, Newton's third law, Bernoulli's principle, and lastly, the principle of conservation of momentum. Our rocket is a reusable launch rocket that is able to load payloads and human beings at the same time, named Nova X. It is built up from referring to Falcon Heavy from SpaceX. According to our research, Malaysia has yet to come up with a rocket that can be used for multi-purposes. Therefore, we aim to design a rocket that can fulfill the requirement of space exploration for Malaysia and help carry out various tasks that are related to space like Mars immigration, satellite launching, etc. The physical model is mainly made up of paper and cardboard with its length 11 cm, width 5 cm, and height 60.5 cm, and its cost below 10 ringgit. Here are some pictures of our model. Our model, Nova X, consists of one main body and two boosters attached beside main body. All the parts in our rockets are reusable except for nose cone. The main body is composed of several parts like nose cone, first stage, second stage, fuel tank, and engine. First stage contains a parachute at the top, payload capsule, solar cell, fuel tank, and engine. On the other hand, second stage consists of a parachute, passenger capsule, escape pod, solar cell, fuel tank, and engine. Now I'm going to talk about the design of our model. The amount of air resistance that opposes a rocket's motion depends mainly on the shape of the nose cone, the diameter of the rocket, and the speed of the rocket. The first point that meets the air is the nose cone at the front end of the rocket. A nose cone with a pointed end can reduce the air resistance as much as possible. Hence, the best shape for a nose cone is a cone with narrower and sharper point at supersonic speed. Rockets with a larger diameter have more drag because there is more air being pushed out of the way. Drag depends on the cross-sectional area of the object pushing through the air. Making a rocket as narrow as possible is the best way to reduce drag. For the number of sub-engines, we think multiple engines is the best option. This is because if you have multiple engines and a sufficiently clever control system, you may be able to survive having one engine fail and shut down unexpectedly during a flight. In our model, only two sub-engines are used as this can reduce the weight of the rocket while providing sufficient thrust force. For the material used to build the outer frame of the rocket, we have decided to choose a blend of lightweight carbon fiber and aluminum composites. These combinations will make the rocket 30% lighter than other rockets of its size. Carbon fiber also improves aerodynamics for the nose and body of the rocket. Carbon fiber is highly suited for aerospace applications due to excellent tensile properties, low densities, high thermal and chemical stabilities in the absence of oxidizing agents, and stability in temperature swing. Rocket engines and fuel tanks are constructed of aluminum alloys. Aluminum alloys are suitable because of their high strength and good toughness over a wide range of temperature from negative 252 Celsius to 1100 Celsius. Passenger capsule, payload capsule, and escape pod are made of titanium. Titanium can withstand the extreme hazards of space including temperature fluctuation, cosmic and solar radiation. Advanced version of reinforced carbon-carbon core two-frog is placed wherever extreme heat could affect the capsule. As for the fuel, we think atomic metallic hydrogen is the most suitable one. Atomic metallic hydrogen is an efficient and clean energy source and the end product is only water. One of the characteristics of a propellant is its specific impulse, ISP. Specific impulse is a measure of how efficiently a reaction mass engine creates thrust. Liquid hydrogen oxygen used in modern rockets has an ISP of 460 seconds. Meanwhile, metallic hydrogen has an theoretical ISP of 17,000 seconds. Atomic metallic hydrogen, if metastable at ambient pressure and temperature, could be used as the most powerful chemical rocket fuel, as the atoms recombine to form molecular hydrogen. Basically, because it takes so much energy to squish hydrogen into its metallic state, when they recombine into their molecular form, they release huge amounts of heat. When it burns, it will be more vigorous than ordinary hydrogen and will release 9 times the energy of ordinary hydrogen and 5 times the energy of current common space shuttle fuel, which is liquid hydrogen oxygen. But pure metallic hydrogen will release huge amount of heat and the chamber temperature can reach 6,000 Kelvin. This temperature is too high for rocket engine material. By diluting metallic hydrogen with liquid hydrogen or water, the reaction temperature will be reduced and safe for the rocket. The concept of solar sail is also introduced to our model. It is added in case the fuel is used up or the booster breaks down unexpectedly. Solar sail is a large thin sheet of aluminum coating on a polymer, which is plastic, that is attached to a spacecraft and designed so that sunlight can push on them, like wind in a normal sail. Scientists think that a solar sail could propel spacecraft to 10% of the speed of light. Solar sailing is a revolutionary way of propelling a spacecraft through space. A solar sail spacecraft has large reflective sails that capture the momentum of light from the sun and use that momentum to push the spacecraft forward. By adding this feature to our model, more fuel can be saved, thereby reducing the weight and cost of the rocket. Now I'm going to discuss about the safety of the model. When a rocket is built, it requires an array of features to keep it and the crews inside safe. A high-tech purifier system are installed to remove carbon dioxide, humidity, and radiation from inside the passenger capsule. The payload capsule are coated with advanced heat shield called AV coat to withstand the extreme temperature, especially during reentry. Our rocket also equipped with backup communication and navigation system to help the rocket stay in contact with the ground. Escape pod is included in our rocket design. The escape pod includes parachutes, airbags, and tracker system. Parachutes are used during ejection of escape pod and the airbags are used to reduce the landing impact when the escape pod lands on the ground. Airbags are also able to make the escape pod float on water when the escape pod lands in the middle of the ocean. Tracker system is used to locate the escape pod. Noah X is carefully designed to meet all the requirements. This rocket is safe, strong, light, powerful, stable, high-tech, and built with extra safeties. This model is a reusable launch rocket. Autonomous controllers and sensors are used to perform propulsive landings. Autonomous barges serve as landing platforms for rockets performing vertical propulsive landings at sea. Special purpose ships equipped with giant nets to catch smaller rocket parts like fairings. Nova X has two boosters to provide optimum thrust force and as a backup engine during launch. Metallic hydrogen is chosen as fuel because it provides more energy as a backup energy. We install solar sail in both stages of rocket. Materials used are light, superstring, and can withstand to extreme heat. Extra precautions are taken to make sure passengers are safe and escape pod is installed to be used during emergency. Last but not least, this model is designed for many purposes with extra compartment to bring more passenger or equipment. Noah X is designed as a multi-purpose rocket. It is ready to be used again. Mainly purpose is to bring astronauts to explore other planets as well as space exploration. Besides that, this model can be used to bring satellites, robots, or scientific equipment for scientific research. That's all for our presentation. Thank you.